everyone. I'm your math teacher, Hatice Yılmaz, and I'm so excited to be with you in this lesson. Let's start and enjoy together. In this lesson, we will learn how to find the circumference in the area of circles. Let's go before we jump into our calculations for circles. We need to know the parts of a circle. The first one is the center point, which is equidistant from every part of the outline or the edge of the circle. There are two important measures of a circle. The first is the diameter. It is the measure of the distance across the center of the circle like this. We can also measure the distance from the center of the circle to the outer edge. This one is called the radius of the circle. Do you notice any relationship between the diameter and the radius? You are right. The radius is half of the diameter. We call the perimeter of a circle the circumference, and the circumference is the distance around the circle. Since there are no sides on a circle, we can use our formula for perimeter, where we add the lengths of all sides instead. We have to find a relationship between the diameter of the circle and the perimeter of the circle. Luckily for us, ancient Greeks spent a lot of time thinking about circles and ratios. An ancient Greek named Archimedes thinks about the ratio between the circumference and the diameter of different circles. Let's explore what he discovered. Here I have a circle with radius 1 and it has been painted along the circumference with green. When we're gonna roll the circle along this line and see where the green paint ends, and that will tell us what the circumference is. Here we want to know the relationship between the diameter of the circle and the circumference of the circle. So we know the radius is 1, and when we unroll the circle, circumference is equal to 2 pi. Observe that diameter of this circle is 2, and so this tells us that the relationship between the diameter and circumference, the circumference is equal to the diameter times pi. We can also plug in the radius because we know d is equal to 2r. We can also say circumference is equal to 2 times p times r. Now let's do this sample example of finding the circumference of a circle. So I have this distance is given to me, and since it goes from the edge to the center of the circle, I know that this is equal to my radius r. So I can plug it into our formula. Here circumference is equal to 2 times pi times my radius, which is 8 feet. So now, if I multiply my 2 and my 8 together, I get 16 feet, and I'm multiplying all of that by pi, and 16 feet times, remember, pi, we can say it's equal to 3.14. And now, if I multiply 16 feet by 3.14, I get 50.24 feet, and that's the circumference. Now, to find the area of a circle, we need to know pi and the radius of the circle. And we can use the formula area equals pi times r squared. So, let's do this example for finding the area together. So, I have this distance is given to me, which is the diameter is equal to 12 inches. Remember that radius is half of the diameter, so the radius is equal to 6 inches. So I can apply that into my formula. Here area is equal to pi, and then my radius is, which is 6 inches squared. And so now this is telling me I have 6 inches times 6 inches times pi. If I multiply my 6 inches together, I get 36 in squared. So now I have area is equal to pi, which is 3.14 times 36 in squared, and that is equal to 113.4 in squared. Now you know the parts of a circle and the formulas for circumference and area. Area is equal to pi times r squared, and the circumference is equal to 2 times pi times r. Now let's watch a video to understand the area formula of a circle logically.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
So now we have learned the area and circumference of a circle, but what about the parts of a circle? Remember that the arc of a circle is defined as the part or segments of the circumference of a circle, and the length formula for an arc is theta over 2 pi, which is 360 degree times pi times diameter. Moreover, remember that a sector of a circle is pie-shaped part of a circle made of the arc along with its two radii, and the formula for a sector area is equal to theta over 2 pi times r squared. So let's do some examples. Here, find the length of the arc subtended by an angle of 150 in a circle with a radius of 12 centimeters. I have a center angle 150 degree and a radius 12 centimeter in a circle segment. So I can plug it into our formula. Here the length is equal to 150 over 360 times pi times 2 times 12, which is the diameter. If I write 3.14 to pi, which is approximate value of pi, and multiply all of them, I will reach the result of 31.42 centimeter. Now let's move on to this example that find the area of the sector with an angle of 150 degree and a radius of 12 centimeter. Remember that our formula for area of a sector was angle over 2 pi times r squared. If we plug these values to our formula, the sector area will be equal to 150 over 360 times 3.14, which is the approximate value of pi, times 12 squared. And if we multiply all of them together, we will reach the result of 118.50 centimeter squared. This brings us to the end of the lesson for today. Today, we learned finding area and circumference in circles. When finding the circumference of a circle, we use the formula 2 times pi times r. And to find the area of the circle, we use the formula pi times r squared. We also learned and did exercises when finding the length of an arc on a circle. We used the formula for that 2 times pi times r times theta over 2 pi is equal to arc length. Furthermore, we learned how to find the area of a sector in a circle. For that, we have area of the sector is equal to the angle over 2 pi times r squared. Our lesson ended here. See you in the next lesson. Bye.